Hey guys, I'm Jeff, CEO here at PowerProbe. Today we'll present our new PowerProbe Hook circuit tester. For the next 14 minutes, you'll hear some very cool advantages that'll help you fix cars fast. We asked Jeff Kogan, one of our valued team members, to present this to you. Jeff, you have the floor.
My name is Jeff Kogan. I'm with PowerProbe, and I'm going to be showing you the new hook. This is a different type of technology that PowerProbe has ever brought you, so let's just talk about it. We're going to show you that it has a 20-foot cord, just like the PowerProbe 3 does. The 4mm banana plugs that have the standard lead adapters, so any of the sets that you have, you'll be able to use. And we kept the flashlight for you. Okay, so the best way that I can show you the hook is just to show you how it works. First thing we're going to notice is I have it connected to a battery, and you'll see there's a voltage reading right here on the bottom of the screen. And that becomes a key point when we start talking about circuit testing. So let's go ahead and test some circuits, and we're going to talk about the features. I'm going to go right here to this power distribution box. We can hear that we have voltage, and I'm just going to turn the speaker off so I don't have to talk over it. And we can see that we have the tip voltage displayed along with that system battery voltage. And that's the first feature that we're talking about. That is the automatic voltage drop. Don't have to do anything. Why? Because we're already connected to the battery positive and the battery negative. With that being said, there's no other testing required because we already have the connections needed. So with the automatic voltage drop basically stating 12.7 volts on the tip and 12.7 volts battery source, you would think that that voltage is good. Maybe not. Well, that brings us to our second feature, the hotshot feature. The hotshot feature basically loads the circuit. On the surface, it looks really good. They match. But we haven't loaded it. We haven't stressed this circuit. Hotshot, and you can ID it by the lightning bolt icon here and the lightning bolt icon on the switch. They're right there. When I press it, we're going to get either a pass or a fail. Let's see what happens. Well, you can see it fails. So the automatic voltage drop showed that they were both the same, but when we stressed the circuit, it wasn't a good battery source voltage. And you'll get the same results whether you're using for battery or ground. When we do the hotshot feature, we see that it fails. That's not a good battery source voltage, or if we are testing ground. If I go to this one, we can see the tip voltage and the system voltage. I'm going to hit this one, and that is a good one. That is a good battery source voltage. Now let me show you an extreme case and how easy this feature is. Notice it's half the amount of voltage practically. 6.4 volts at the tip, 12.7 battery source voltage. And if you take a really good look at the screen right here where the hotshot icon used to be, because the tip voltage is so far away from the battery voltage, there's no point in having that feature. So with that being said, the hotshot feature, when it's available, look for the icon. If it's not available, don't waste your time pressing that button. Now, let's talk about how we use this with what's called the smart tip technology, which is the next feature that I'm going to talk about. Customer comes to your shop and basically says, something doesn't work. My dome lights, maybe it came towed in, the fuel pump crapped out on it. Okay, we're going to remove the relay, a nice central point, so we could do circuit testing for everything for that particular failure. Unplug it. We have 4 terminals in this case. We have a nice little breakout box where all the leads for that circuit we can test. One central location. We go right in. And what the smart tip technology is I'm going to go right in, turn the speaker back on, pick the voltmeter, ranged it for me, and we can see 12.7 and 12.7. Is it a good source voltage? Let's hotshot it. And it passes. That's 25% done already out of the 4 circuits. So we know that this is a good battery source voltage. Now I keep mentioning smart tip. Here we went from voltage. Now let's do the second. We go right into an ohm meter. Watch that again. I'm going to go from a voltmeter to an ohm meter. So the smart tip has sensed the type of circuit, picked the correct type of meter, and automatically ranged it for me. Now that I have that information and I see the resistance reading, I can put a power and power this circuit up. We can see right here, I'm just going to turn the speaker off, that I have whatever this device is now working, but more importantly on the screen is the amp reading and the internal resistance with the current going through it. And I'm going to talk the importance of that in my next segment. So up until now, we've tested 2 of the 4 circuits. We're halfway done. Let's go to the third one. The smart tip has picked a voltmeter. Let's hotshot it. It's good. 3/4 of the way there. Let's do the last one. Well, the last one, if you notice, the preference line of how the tool is set up, nothing's changed. That means it's an open circuit. But let's keep in mind, we got to make this relay work. We have to make it click. Something has to turn it on. Well, maybe it's controlled by a module. We go into our scanner module, our scan tool, let's say. Maybe it's something in the body control module. If that's the case, we go into the function manual and activate it. Doing that, I can confirm that all 4 of these circuits for this device work fine. And now if any one of them had not worked, we would have been able to figure out right from this one central location what to do. I didn't even have a wiring schematic. That's the point of using the smart tip technology. Now, what we have to understand is this relay, like every other circuit in the vehicle, has protection in it. It has different fuse levels. Well, what's really nice with the hook is the automatic circuit breaker. We have the ability to adjust and match the same size circuit fuse protection that the manufacturer has. What we do is we just press the select button and we can see easily circuit breaker, and we can pick the same size fuses. And that's a pretty big important point right there. So in this case, I'm just going to go right on down. I'm going to go to 2 amps because we're going to test that fuel injector. I hit select, and you'll see the 2 right there in the corner showing me 2 amps protection. Now, one last thing about the circuit protection I want to talk about is, yes, we're going to match the same size fuse, but these automotive fuses take a few hundred milliseconds to vaporize the metal or blow the fuse. Our circuit breaker in the hook happens much quicker. So instead of a few hundred milliseconds, it happens in microseconds. So what that really means is the hook will expose the vehicle to a harmful type of current for less time than the manufacturer's fuse would. You really can't do any damage. Now, please keep in mind that SRS or airbag systems do not get tested in this way. Those systems are completely disabled, modules are unplugged, simulators are put in. That's my disclaimer. You have to know that SRS systems don't get tested like this. With that being said, let's show you what we're going to do now with this fuel injector. We're going to connect. It's simply just going to each wire. We're going to be able to see that the hook went right to an ohm meter. That's the same way that your regular meter would do this, not loaded. So now what we have the ability to do is to activate it and see the current and resistance. And I'm just going to turn that speaker off, and that's done by pressing the speaker button 1 time. I'll activate it again, and there's the amps and the resistance. Now that's a pretty big crucial point right there, because let's say you were to replace a module in a vehicle, PCM. Wouldn't it be nice to unplug that computer, and before you plug that new computer in, make sure that the new one isn't going to have the same problem the old one has? So what I recommend, and what PowerProbe is designed the hook to do, is let's hotshot all the powers and grounds. Simply put, you just have a wiring schematic of the header of the vehicle that you're looking at. Go to all the powers and grounds and make sure they all pass and fail. Do that test. Next, what you're going to want to do is go to all the injectors, all the ignition coils, transmission solenoids, evap solenoids, any of the loads that the computer turns on, and you can activate them, and you'll be able to see the internal resistance and the current draw on each one of them and pick out what's going on. Basically, one of 2 things is going to happen. You're either going to find what blew the computer up to begin with, fix it, or you're going to confirm that the vehicle doesn't have a problem and that only the computer is bad. Basically, you're going to avoid this situation. Let's go to this fuel injector. We're going to just go right across the 2 wires. And again, here now we're showing 7.2 ohms. I'm going to activate it, and you can see that it has blown my circuit breaker because it only fails with the current going through it. That's a big key point right there to understand. Now, if this had been a Honda evap solenoid, the new fuse would have been that computer that you would have installed, and that's something that we need to avoid. It would have been very nice to have the hook so that he could have confirmed all the solenoids or control devices that the computer controls is good before he plugs that new fuse, computer in. So now we're going to go to larger current devices. Because remember, the hook can go from 2 amps to 65 amps. So we're going to connect. We're going to go right to the 2 wires on this fan, and we can see the smart tip goes right to an ohm meter. Let's activate it. Pop my circuit breaker immediately. Well, why is that? Well, if we take a look, I had set it for 2 amps. Simply do it, press select, go to 65 amps. Now you can see in the corner, we have 65 amps. We're going to select the amount of current we need. We connect it, we go right to that ohm meter, we ranged it, power it up, there's my amp and my ohm readings. While powered up, you're getting that resistant reading. That's a big deal right there. Now, so that you get a better understanding of what the smart tip technology is and what the advantage of using it is, this right now, this cooling fan, we're supplying voltage into it, making it spin. When I let go of the power button, this motor becomes a generator and they're going to produce a voltage. You're going to see the hook go to a voltmeter. When the motor stalls and the fan blade stops, it's going to go to an ohm meter. So let's watch the screen. I'm going to let go now. There's my voltmeter. There's my ohm meter. And the point that I'm trying to show here is that this tool becomes an extension of the technician's hand. He just merely goes to whatever circuit he is, doesn't have to make any decisions about the type of meter or ranging it. It's going to adapt ongoing to what circuit he's going to. And that's kind of a big deal. That's what the hook is all about. One of the other key features about the hook that I'm very excited to share with you today is the fact that for the first time ever, we have a computer-safe tester. Well, how do we get to it? How does it work? When we first power up the hook, it's in the PowerProbe Hook mode. And that's what you've seen up until this point, how it automatically adjusts to the different situations. Well, I'm the technician. I'm going to tell the tool what to do now. I'm going to take it out of that mode. We simply do that by pressing the select button. And the best way to think about this is that we're going down a hallway to the different features. I press the select button, it says circuit breaker, and that's the first room in the hallway. And as we continue to press either up or down, we're changing the different modes. And I'm looking for voltage reference mode. The voltage reference mode is the mode that I need to show you right now. Press select, and if we take a look at the screen, we're able to go from half a volt, 1 volt, 1.5. We can go from half a volt to 5 volts in half-volt increments. I'm going to put it at 1 volt. That's where we should be. 1 volt going out, and here's the kicker now. It's 20 milliamp maximum output. So we're not going to harm anything at 20 milliamps. Where do we use this tool? Why is it so powerful? Well, let's say you're working on a vehicle and there is an O2 sensor circuit failure, a TPS circuit failure type code. Why not just go to the O2 sensor, unplug it, take the 1 volt, put it in that connector. Now that's set up sending 1 volt in. Go to your scan tool. If you see 1 volt, that whole circuit and computers, everything's good. If it's not there, okay. What you're going to want to do at that point is take a PowerProbe 3. The tools are used in conjunction with each other, not as a replacement. Take your PowerProbe 3 and go right on down the line of that harness and look for that 1 volt the hook is producing. When you find where it is and where it isn't, you fix the problem of the vehicle. So with that being said, that's just one added feature that has been to the hook, computer safe tester. And that's in the voltage reference mode. Be on the lookout for some of the other videos that are going to be coming out real soon. The arc detection mode and the separate relay harness video is going to be out. Until next time, this is Jeff Kogan saying, get out there and fix some cars.